Imagine waking up one morning and discovering that your body no longer has a normal shape. You are no longer made like a human being with arms, legs, and a coherent structure in space, but your body has taken on a shape that seems to violate the rules of geometry itself. Something similar to the impossible objects that are sometimes seen in mathematical drawings. From far away, you might appear normal, but as soon as someone tried to follow its contours, they would notice that something is wrong. One part of the body would seem to connect to another in a way that could not exist in three-dimensional space. To understand how strange it would be, you have to think about one of the most famous mathematical examples of an impossible shape, the so-called Penrose triangle, an object that appears as three bars forming a perfect triangle, but that in reality cannot exist as a solid object in normal three-dimensional space, because its parts connect in a geometrically contradictory way. In a two-dimensional drawing, it seems coherent, but if you try to build it for real, you would discover that some parts would have to be at the same time closer and farther away in space, something that violates the rules of Euclidean geometry in which we live. Now, imagine that your body works like one of these impossible objects. You could have an arm that seems to connect to the shoulder, but that at the same time goes back and joins the body again from another direction, creating an impossible geometric loop. Your brain, used to interpreting the world in three dimensions, would not even know how to perceive you correctly. In fact, impossible objects work precisely because our brain always tries to interpret lines and perspectives as solid objects in space. When the visual information is contradictory, the mind continues to change interpretation without being able to find a coherent structure. If your body really had a geometry like this, it would not only be difficult to see, it would probably be impossible to describe with normal physics. The reason is that our universe is built on three spatial dimensions. Every object that exists must follow certain very precise geometric rules. Surfaces that meet in a coherent way, volumes that cannot intersect with themselves, and distances that cannot suddenly change without deforming matter. If your body had an impossible shape, some parts would have to occupy two different positions at the same moment, or connect through paths that do not exist in three-dimensional space. In mathematics, this type of problem is connected to topology, the study of the properties of space that remain the same even when an object is deformed. Some strange shapes, like the Mobius strip, can actually exist because they still follow the rules of three-dimensional space, but other shapes, like certain impossible objects, would require extra dimensions to truly exist. In fact, some mathematical analyses show that the surface of figures similar to the impossible triangle could exist only if it were embedded in a space with more dimensions, such as a five-dimensional space. If your body really had a geometry like this, it would probably mean that you live in a universe with more spatial dimensions than the ones we normally perceive. In theory, modern physics does not completely exclude the existence of extra dimensions. Some theories of gravity and particle physics suggest that space could have more hidden dimensions on very small scales. In such a universe, your body might seem impossible to those who live in three dimensions, but perfectly normal if seen from a higher perspective. It would be a bit like looking at the shadow of a three-dimensional object on a sheet of paper. The shadow can have very strange shapes that do not seem possible in the plane, but they become understandable when the extra dimension is considered. Of course, even if it were mathematically possible, your body with an impossible shape would cause enormous problems for physics and biology. Blood would have to flow through paths that intersect with themselves. Bones would have to support structures that change direction in space in a paradoxical way. And even gravity would act in ways that are difficult to predict. Some parts of your body might seem close to each other, but actually be at great distance along the real geometric structure, while others might be connected by paths that seem to cross space like invisible shortcuts. For an external observer, it would be like watching an impossible puzzle that continuously rearranges itself before their eyes. In a certain sense, a body with an impossible shape would be a window into a deeper reality than ours. It would show that the space in which we live could be only a small part of a much more complex geometry, where the rules we consider absolute are only particular cases of something greater. And perhaps the most fascinating thing is that these ideas do not belong only to imagination. They arise precisely from modern mathematics and physics, which often discover structures of space so strange that they seem almost impossible, at least until we learn to look at them from a new dimension.